All right, second method that we use to solve a system of equations is elimination. Okay, this works when you have the variables stacked on top of each other. So that's what you want to really look for to be able to use this one. So see how the x's are on top of each other, then the y's, and then the constants over here. Okay, once you notice that, then the second thing you need is for the two numbers to be the same, but one of them's a negative and one is a positive. Because we're going to add these equations straight down, and we need one of the variables, either the x or the y, to cancel out. Because once we have one of them canceled, we can solve for the other one that we still have, and then once we know one variable, we can plug it back in. So we have exactly what we want right here. We have a negative and a positive. So if we add these together, these are going to cancel. Negative 4 plus 4 cancels. Okay, these two, negative 2 plus 8 is 6y. And then these two, they're both negative, so we just add the numbers together and the sign stays the same. So negative 36. And then we divide by 6 to get y by itself, solve for y, and you get y equals negative 6. Okay, you're not done yet. That's halfway done. Now we have to plug y back into either one of the original equations. It doesn't really matter which one. Okay, I'm going to choose the top one just because the numbers are a little smaller. Smaller numbers are easier to work with than bigger numbers. Alright, so that's negative 4x minus 2 times y, which we now know is negative 6, equals negative 12. Alright, and solve this for x. So multiply those together. That equals positive 12. Negative times negative equals negative 12. We're going to have to subtract 12 to the other side to cancel it out. And that's going to equal negative 24. And then finally we're going to divide by negative 4 to get x by itself. So x equals, the two negatives cancel, 24 over 4 is positive 6. So our solution on this one, remember we still write it as a coordinate point, 6, negative 6. Okay, now the problems aren't always as nice as that, but it's still the best way to solve it is elimination. So like this one, we've got everything stacked on top of each other, but the two 9s, they're both the same sign. So we need one of them to be a plus instead of a minus, so they'll cancel. So we can just multiply the whole equation by a negative 1, and that'll change the sign. Now you got to make sure you do all three terms. If you leave one out, you're going to get the wrong answer. So we got to change that to a positive 2x, this changed to a positive 9y, and this changed to a positive 25. Alright, so the 9y's are going to cancel. Negative 4 plus 2 is negative 2x, and negative 23 plus 25 is positive 2. Divide by negative 2, and you get x equals negative 1. Now, plug them back into one of the original equations. Don't use this one where you multiply by negative 1. Use one of the originals. Okay, so that's going to be, let's use the bottom one. All right, negative 4x, which we now know is negative 1, minus 9y equals negative 23. So that multiplies out to positive 4 minus 9y equals negative 23. We need to subtract 4. Negative 9y equals negative 27. And then I need to divide by negative 9 to cancel it out and get y by itself. Y equals positive 3. The negatives cancel, and 27 over 9 is 3. So our solution on this one is negative 1, comma, positive 3. Circle this one over here as well. Alright, a couple more examples here. This next one, again, the x's and y's, and they're all stacked on top of each other like we want, but now the numbers aren't even the same. Okay, much less the signs being different, the numbers aren't the same either. Okay, so you can still do it. We're going to have to multiply both equations by something. Alright, so you need to decide what's going to be the best or easiest to cancel out. On this one, it's really either one, it doesn't matter. I'm going to go with the y's just because their signs are already different, so I won't have to multiply by a negative as well. But you could just as easily cancel out the x's if you want to. So I need to multiply this by a 9 up here, and I'm going to multiply this one by a 4. Okay, that's the easiest way. Just multiply them by the opposite of each one. Okay, sometimes you can multiply by a LCD, a least common, well, let's say LCM, a least common multiple. All right, but if you don't want to figure that out, just multiply them by each other. So everything on this top one gets multiplied by 9. Everything on this bottom one gets multiplied by 4. Okay, so that's going to be 45x plus 36y equals negative 270. Down here we get 12x minus 36y. That's what we're looking for right there. Those are going to cancel. Equals negative, we got 72. 45 plus 12 is 57x. These two cancel each other out. And negative 270 minus 72 is negative 342. Alright, and we need to divide by 57. Okay, I'm going to go ahead and use the calculator for this part. So if we go to the calculate page, we have negative 342 divided by 57, which is negative 6. So it worked out to be a whole number for us. X equals negative 6. Alright, now we have to plug that back into one of the original problems. Okay, I'm going to use the bottom one. Numbers are a little smaller on that one. So 3 times negative 6 minus 9y equals negative 18. Okay, that's negative 18 minus 9y equals negative 18. We need to add 18 over here to cancel it out. And when we end up adding 18 over here, that's going to end up canceling that out as well. Okay, so that gives me negative 9y is equal to 0. And even after I divide by negative 9, that's not going to change my answer. Y is going to equal 0. So my solution here is negative 6, comma 0. Alright, last one over here. This one's all jumbled up. You see how the x's aren't on top of each other, the y's are not on top of each other. The constants are right now, all right, but we want to move it around so it looks more like this one on the left. Okay, so in this first one, I'm going to start by subtracting 3. That constant should be on this other side, and that'll give me 2x minus y equals negative 3. All right, on this one, I need to move the 3 over, so I'm going to add 3. But I also need to move the 10x over. So I'm going to subtract 10x as well. Alright, so the 10x's are going to cancel here. The negative 3 is going to cancel here. So I end up with negative 10x minus 7y equals positive 3. Alright, now my numbers aren't the same. So you got to pick which one. Okay, what I'm seeing here is that if I multiply this 2 by a 5, it becomes a positive 10, which will cancel out with the negative 10. Okay, if you saw something else faster than that one, go with that. Okay, it's all about you being able to figure out what the best and quickest and most efficient way to do this. So 10x minus 5y equals negative 15. Alright, the 10x's are going to cancel. That equals negative 12y. This equals negative 12. Divide by negative 12 to cancel it out and get y by itself. Y equals positive 1. Negatives cancel. 12 over 12 is 1. Plug it back into one of the original problems. Again, does not matter which one. I'm going to use this bottom one right here. So I kind of put some x's through some things, so let me erase real quick. Alright, so we got that. We had negative 3 there before. Alright, so that's negative 3 minus 7 times 1 equals 10x. So negative 3 minus 7, that's negative 10 equals 10x. And divide by 10. Negative 10 over positive 10 is negative 1. So our solution on this one is negative 1, positive 1.